All right. So this is Intro to Engineering Design. and it's kind of like half in person, half online content. Um, Today, what I'm going to do is just describe the class and go through the syllabus. And then I'm going to show some videos of projects that people did last semester. Um, and then we'll do we'll run over across to the next hallway and do a little walkthrough of the Fab Lab where we have all our fabrication equipment and stuff, talk about what kind of stuff is available. And then after that, I don't think that'll probably take the full class time, but that's all we're going to do today. And then you can just look online there'll be sort of like a video lecture and some assignments and stuff to get stuff started. Okay, so today we're just sort of introducing things. Everything for this class is going to be on D2L, so get in the habit of checking D2L every day. You can see instead of lecturing on the board, I'm going to be lecturing on a tablet that's going to be projected up there. Just treat it the same way as you would if I was writing on a whiteboard. But you can see at the bottom, I'll be recording all these too. So if you can't make it to a class or you want to revisit something that went by too fast or whatever in class, all of these videos are going to be available along with, when I'm writing stuff, PDFs of the notes I write. So hopefully that'll be helpful. Okay, so D2L. When you go into D2L, you should have a list of all your classes. So this is Engineering 1020. Go in there, and the first thing you'll see when you go into the class D2L is the list of all the announcements. And this is what you should be checking, just, check at the same time every day, just get in the habit. If I put up a new assignment, if I change an assignment, if I correct something or whatever, if there's a test coming up, this is where I'm going to always alert you to that kind of stuff. So just look at that. And then as we get going, grades will be posted. You'll be putting things in the assignment folder. But today, all I want to talk about is under content, where the syllabus is and stuff like that. There's not too much here yet. As we go, I'll post like assignments here. I'll post lecture notes and lecture video links here. So content is where you'll find all the lecture videos, all the problems for assignments, that kind of stuff. Today, we're just going through the syllabus. So here's the class. It's a 4-credit class, which, it's always pretty hard to figure out exactly the right amount of work to assign or whatever. But a good kind of rule of thumb, ballpark idea of how much work you should be doing with everything all in for a 4-credit class. So 4 credits means, nominally like four hours of lecture type stuff per week. And then a college class, the general guideline is you should be doing 2 to 3 hours of work outside of class for every hour in class. So if we take the 2 hours outside, take the low end of that, okay, which I think is probably enough for this. I think that'll be enough for you if you're doing about that much work. You'd have 4 hours of lecture, and then you'd have 8 hours of outside work. And so you should be expecting to look at somewhere in the ballpark of 12 hours of total time devoted to this class per week. Okay. And I think often when we start getting into some of the skills and things in this class, not all of that time will be just on stuff that I assign, like a lot of what you should be doing in this class is reading back over old uh, lecture notes, reminding yourself about the stuff that I've taught you, going back over old problems to remind yourself how to do that stuff. So just when you have extra time in a week, think about doing that kind of stuff. And I guarantee if you're doing all the assignments on time and you're going back and reading the notes occasionally and you're going back and redoing problems occasionally, you're going to have a really good experience in this class. Okay. My name is Gaio Lakin. Just call me Gaio, please. My PhD is in mechanics, so kind of like engineering math, kind of like a classical sort of traditional engineering math education. And I did a master's in biomedical engineering before I did that PhD in mechanics. Both of those were at the U of Minnesota. So I spent a lot of time in the engineering buildings at the U of Minnesota, if anyone has any questions about that. Also, just for fairness in advertising or whatever, while I'm mentioning the U of Minnesota, I also am a big fan of Twin Cities Engineering over here. So, if anybody ever has any questions about that, I'd be happy to talk about Twin Cities Engineering too. Sort of a different approach than the U, and they're both great at what they do. My office, you really won't need that. I don't do my office hours there. I do them elsewhere. You can contact me by email, but the best way to contact me is to use this, that mail, that envelope icon up there in D2L. It's just organized a little better for me, so I'm less likely to lose sight of your email and then forget to email back. If you do send me a message in any format, and I don't get back to you in a day or whatever, then I'm sorry about that. Just send another message and, remind me or whatever, and I'll feel horrible about it. But it still happens sometimes. But this one, usually I don't miss these messages because it's just organized so nicely. The thing with email is I'm getting like a million emails from all sorts of places every day. So class time, room. And then here are my office hours. This one probably in 2120 doesn't help you too much, although if you want to seek me out during that time, you're welcome to. But that's just a 40-minute block in between two of my other classes in the classroom where it is. So it's mostly mainly going to be people in one or both of those two other classes. But you're welcome to come if you'd like. And then my other ones are in the tutoring center, Tuesdays from 1 to 3. So the day of class, so after class, there's like basically an hour for lunch or whatever. And then I have office hours. And then Wednesdays from 2 to 3. And then if those don't work for you, I always can make Zoom appointments or whatever too. The only prerequisite for this class is college algebra. And and the topics to be covered in this class, we're going to spend, a week or two just talking about the different engineering disciplines. Since this is the first engineering class a lot of people take, I think it's probably helpful to just get a sense of what do you do in chemical engineering, what do you do in biomedical engineering, etc. And then, this is sort of a leftover thing. I used to spend a bit more time on the history of product design. I'm going to de-emphasize that a little this semester. But then we're going to get into some real skills, including some computer-aided design. And like I said, I'll show you the Fab Lab today so you can see what kind of machinery and equipment we have available to us. It's a great resource. And We'll talk about circuits, uh, data sheets and electronic components, programming, and then the last 8-ish weeks we'll be just doing robotics projects. And I want to, after I'm done going through the syllabus, I'll just show you the videos people turned in of their robotics projects. It's just so much fun. It's not, I'll tell you, it is not fun if you go 6.5 weeks of not doing anything and then try to finish an 8-week project in the last week, or whatever. But as long as you're just sort of staying consistently on it, it's a really, really fun process for you and for me. The grading will probably be 90, 80, 70, 60, unless there's some reason I have to curve it. It won't be any higher than that, but if the test scores are lower than I meant them to be or whatever, maybe I'll curve it down a little, but usually it stays right about this. And then the grade breakdown is this, and I'll talk about all these individually. The first one I'm calling professionalism, consistency, and appropriateness. And then lecture quizzes, weekly assignments, exams, the first design project, and the robotics project. And that all adds up to 100, which is great. So let's just go through these one by one. So the first 5%, that's 5%. That's not a big chunkier grade, but it's half of a letter grade. I'm calling this category professionalism, consistency, and appropriateness. And the basic idea is engineering is a professional degree. There are going to be certain expectations of you when you go out into the workforce, and really similar expectations before that when you transfer to the university. And so I'm just going to try to sort of help you stay on the right track with this stuff. And so it's really just a list of it's a list of the kind of things that make you somebody that people want to work with, on group projects, as an employee, all that kind of stuff. And I want to say something. So the first one on here is attendance. And that's important, but right now this semester, we can definitely work around that. Okay, I know things are crazy right now and crazier for some people than other people. And so the last thing I want is for anybody to feel obligated to come here when they don't feel like it's safe to be here. But if you feel like you're better off staying away from class for the time being, please just keep me updated. Okay, so keeping me updated is the equivalent of attendance right now. Don't just disappear and assume you'll talk to me in 4 weeks, or you know what I mean. Just keep me updated on what's going on, so we can have a dialogue about that. The next one on here is punctuality. Just we only meet once a week, so don't be late. Be here at 10 o'clock. Okay. We're gonna do our quizzes at the start of class. They're gonna be 5 to 10 minutes long, and if you come as we're finishing the quiz or after the quiz, I'm not doing any makeups for that. Then consistently turning work in on time. Everybody has scheduling issues. Sometimes it doesn't work out. I'm always happy to be lenient with turning stuff in a little late or whatever. But if you're doing it consistently, that's just not doing the job of being an engineering student, At exams and classes, have calculators and writing utensils with you. It's just part of being prepared. It's really like, on top of other stuff, all this is kind of just image control. Like, I think a lot of people would be surprised how much bad will gets developed on this stuff that seems kind of what am I trying to say? That seems unimportant, appropriate participation in class. So just, I love to answer questions. I love when people ask questions, but there, for a small number of people, there sometimes gets to be a point where participation in class crosses over into being sort of a distraction that affects the flow of class. It's a very small number of people, but be monitoring, like, am I talking more in class than everyone else in the class combined? That kind of thing, you know. There's a line there where it goes from a positive to a negative, and I'd be happy to talk to anyone who's curious about that. It's such a small number of people that's an issue for. Reasonable use of exam rescheduling. I can do rescheduling of exams, but if you're expecting that all the time, that's too much, you know. Please try to fit your schedule into the class schedule. If you're using the OSD office, please give me the purple forms filled out and ready to go. When you turn in work, there should be, yeah.
Do you know when the exact date for the exam?
Yeah, I do have them down here below. We'll talk about that. Let's see, somewhere down here. Yeah.
Okay.
Your work needs to be legible and clear. So some people do that more naturally than others, but if you have trouble, if that's something you have trouble with, you know, it's an important skill to develop. So that's going to be part of this. You know, no excessive lobbying for grades. I'm always happy to talk about if you think I missed something on a grade or whatever, I'm happy to talk about it. But if it's every assignment, every exam, like trying to get a point here, 2 points here, that's too much. And then following assignment instructions. I think the biggest one is just the formats of the files that I ask you to submit. You know, read what I said with some care and turn it in the way I ask you to. Anybody have any questions about that? So that's the longest one of these, and it's worth 5% of your grade. But then next, also 5% of your grade is lecture quizzes. So especially at the start of the class, most classes will start with a 5 or 10 minute lecture quiz where I'm just asking you to repeat some of the stuff that I said in the week's lecture videos and things, just making sure you're going back over your notes and rereading your notes. Then 10% of your, 20% of your grade is weekly assignments. So by the end of the day, every Tuesday on D2L, I'll post what the assignment is for the week before like the next Tuesday. The due dates are always listed as the next Tuesday at midnight. You know, the 11:59 p.m. the next Tuesday. So basically, if you can do the assignments before the next class, or at least a big chunk of it before the next class, that works better. But you don't have to turn it in until the night of the next class. Are you with me on that? That didn't feel very clear, but yeah.
Are the assignments at least put up at least like a week before?
Yeah. Okay. So like every Tuesday afternoon, I'll post the assignment for the next week, and then it'll be due the next Tuesday. And in fact, it says that the due date is Tuesday, but in the Dropbox, it always gives you a day extra anyways. So really, you can always turn it in up until midnight on Wednesday, you know. But it's beneficial if you can at least do a considerable amount of that work before the class, because the next class will often use the stuff from that assignment. And then exams, the exams only add up to 20% of your grade. There's 2 of them, so each one is 10% of your grade. So it's not a huge chunk, unlike, you know, most engineering classes. these are the dates, and I haven't seen the final schedule yet, but I'll get that to you soon. But the first one is Tuesday, March 17th, and then the second one is whatever our scheduled finals period is during finals week. Um, and then, yeah, you know, uh, I guess um, cheating in this class probably could only come up in exams, really. Um, I'm not going to be trying to figure out if you're doing your assignments using AI, really. I mean, the assignments that I give you, the calculation type assignments, are really just the way for you to learn how to do the stuff that you're going to have to do on exams and things. So it wouldn't help you much to, just copy. So, um, yeah, so this is a class where really, unlike any of my other classes, unlike probably most engineering classes, um, feel free to use AI, outside resources, whatever, for the most part. The exams are really the only thing um, where you're not allowed to use that kind of stuff. When we get into the projects, uh, if you want to use AI for ideas or whatever, feel free. Well, actually, there are going to be some written assignments, and I don't want you to write those using AI. So that's another thing. I'll come back, and when we get to the assignments, I'll tell you more about what I'd like to see. Yes.
Um, how many projects will we?
There will really only be two big projects. One is going to be individual, and then one is going to be a group project. Uh, the individual one is going to be like a mechanical part or uh, product of some kind, and then the group projects are going to be the big robot project. Um, and then the rest of this stuff, you feel free to look through it, but it's a lot of stuff just provided by the school. Um, Anybody have any questions about the syllabus or the course structure? Okay, well, I thought it would be fun to look at some of the videos of robot projects from the last semester, um, sort of see what kind of stuff we're going to be doing, um, and then after that, we'll go over to the Fab Lab. Okay, so um, these projects are very open-ended. There's a lot of different kinds of things you can do. And I'm going to just show you what we had seven groups. And these are what the 7 groups uh, did last semester. So this first one is like, it's small. It was sort of like a prototype thing, not a full size thing. Largely just because of how awful it would be to try to lug a bed back and forth into class. But it used weight sensors and things. So it was an alarm that, like, if you try to turn off the alarm and then get back into bed, it'll go back on and that kind of stuff. Um, so here is that one. Wrong one. You can see how much electronics we're going to be doing in the second part of this class. The next one, so this is a balls roll down this ramp and it sorts them into the different colors as they roll down. Simple but cool. I'd never seen anyone do this before.
If I could just shoot the rock over them.
Yeah, I wonder if they're heavy or something. That is funny. Little too hard. One thing to notice on this one is some of these key components were created in the Fab Lab. That arm and all the orange pieces here, those are 3D printed parts. And so these robots, we're going to take advantage of all the manufacturing stuff that we have. The third one is the drink mixer. So this just has a lemonade and a iced tea button and then a Arnie Palmer button. So it'll mix it however you want. You know, simple idea. It has an optical sensor in it, so it won't dispense anything until you put a cup underneath, you know. And so I think a lot of times the best projects are the ones that are simple, but they've just thought of a lot, you know, like they've just done a lot of troubleshooting, problem solving. So here's this one. The they put a lot more work into the execution than the aesthetics, but that's all right. Oh, and notice this. He didn't mention it, I don't think, but notice the digital readout out here that's telling you what's dispensing. It's like it could not be a more simple project, but it's just well executed, with the possible exception of the tape labels and stuff. Um, okay, this was probably the most ambitious one, and it didn't work great by the end, but I mean, it's fine. They did a great job. They dealt with some really hard stuff. They got a great grade. But it's a foosball goalie. Hey, wait, you're not a foosball goalie? Oh no, I guess I don't have. Shoot. Do I have it somewhere else? No, I don't think so. Well, maybe I'll show you that one some other time. But they built this really cool like motor system for the arm of the goalie of a foosball. Can you picture what foosball is? And so it had sensors around and it would move in and out based on where the ball was coming. And then it had a motor on it, so it would spin the ball to kick it away. It was really cool. It didn't work great, but it was a fun project to watch them work on. This next one, it's another simple one. You can find a million people doing stuff like this online, but it was well executed. The video really doesn't show the chassis of the vehicle super well, but the chassis was beautifully 3D printed. Everything just looked really nice and clean. And their electronics, you saw for the most part, people were doing their electronics with what are called breadboards, just pushing little wires into this little white board. But they did a lot of their electronics on a printed circuit board, which is something that we have access to in this class. And I'm going to try to incorporate it into the class. We'll see how that goes. But so instead of pushing wires into places where they can fall out and stuff, you take these copper sandwich boards and you design your circuit digitally and then put it into a printed circuit board mill, and it mills out the circuit so that there are no parts that no wires to fall out or anything. It can be nice and small. It's just a really clean, durable way of doing this stuff. Okay, so line following robot. The blue is the chassis. I'll tell you if I can see the. I think the circuit board, unfortunately, might be underneath. There's still a lot of wires. You can't get away from wires completely because of the microcontroller that we use, but yeah, that was a tease. Yes, he does. He does have at least one baby in that house. And so this next one is a leak detector on a pipe. Again, nice and simple. There's a moisture sensor. So water flows through this pipe until they allow some moisture to be sensed, and then it shuts off the pump and keeps water from spilling everywhere. Obviously, like this could be such a useful thing in a million places in a home. So you can see they're just using that valve to simulate a leak, and then so there's not much there, but there's a pump pulling water from one side to the other, and then when that valve opens to simulate the leak, the alarm light goes on and the pump stops.
How do they detect the leak?
Well, actually, you can get moisture sensors. So I think they're just using some kind of moisture sensor. I don't remember exactly where it is, but that's what they're doing. When we start talking about the robotics stuff, I'll talk about all the different sensors that are available. By the way, you might have to buy some of your own stuff. We have some stuff, but if you need something specific, you'll have to buy it. You can usually get it on Amazon in a day or two, and they're pretty much all less than $10, so it's not a big expense. A big part of this project was just getting that pump to work. But that was a good one. And then this one, this is just a stirrer of some kind. You can see the stirring. Yeah, right. I mean, they did fine. This was a fine thing. Their 3D printed part was cool down there. The electronics worked. It could have had more stuff in it, but that's a perfectly fine, good project. Okay, any questions about that? Anyways, doing that stuff is fun. And by towards the end of the semester, really just this entire class time is just going to be you guys sitting at tables working on your projects, and I'll just be walking around helping if you have trouble with debugging or wiring or whatever. So it's going to be mostly, this class is going to be just a lot of hands-on stuff. Okay, anybody have any questions about the class so far? Let's go over to the Fab Lab and see what kind of stuff is available there.